Hello and welcome to helpyourmath.com. In this video, we're going to look at an example of graphing an absolute value function using the transformations of functions. We're given f of x equals the absolute value of x, so this is defining the parent function, and we're given its graph, which is shown on the graph below. Using our knowledge of transformations of functions, we're going to sketch a graph of g of x. These transformations of functions are usually of the form a times f of x minus h plus k, and the a tells us two important pieces of information. The first thing we check for is the sign. The sign of a will determine whether the graph is going to continue to open up like we see, or if it will open down. If a is positive, then the graph will open up, and since this is absolute value, it kind of looks like the letter V. If a is negative, the graph will reflect about the x-axis and it will open down. So we see that our a is negative, therefore our v will be an upside down v. The other thing that a tells us is whether there's a vertical stretch or shrink. If we would say the absolute value of a, like if we ignore the sign and we just look at the number, so I see the number 2, because it's bigger than 1, that indicates that there's a stretch. So the other thing we look for with a is we look at the absolute value of a, and if it's greater than 1, then there's a vertical stretch. And if it's less than 1, then we would say there's a shrink. If it equals exactly 1, then there's no stretch or shrink, and it would maintain that same shape, so the same kind of like the slope of the two segments or the two rays that we see. But a stretch would pull it up, making it closer to the y-axis, and a shrink would kind of widen it and make it a little bit flatter, closer to the x-axis. The other thing we're interested in is locating the vertex of this graph. So the interesting piece of this graph is that vertex. It's where the graph changes direction and goes from having a negative slope to a positive slope, but when we flip it upside down, it'll be the opposite. The vertex of the given graph is at 0, 0. We're going to use the other two values that we see to identify the vertex. The vertex will be of the form h comma k. Notice that h, it's kind of like the opposite of what we see because it says x minus h. And if we look here, it says x minus 3. So 3 is the x coordinate of the vertex. If it was a plus, if it said x plus 3, then it would be the opposite of that. It would be negative 3. So when I usually tell my class inside opposite, and then the k is exactly what we see. So it's plus k plus 6, so it's a positive 6. Once we have these pieces of information, you can either sketch the graph, or if you still don't feel super confident because there is a stretch, what I suggest doing is making a table of values. Now, you have to be very careful about making your table of values because you need to make sure that you get not only points to the left of the vertex, but also to the right. So my suggestion is you do 5 points where the middle one is the vertex. So we want this middle one to always be the vertex hk. And then we want this to be h minus 1, this to be h plus 1, h plus 2, and h minus 2. Because this is an absolute value graph, there is a lot of symmetry, so we actually only have to do half the work. Because if you look carefully at this graph, if we go 1 over to the left of the vertex and 1 over to the right, those provide the same y-coordinate. 2 away from the vertex on x provide the same y-coordinate. So once we have the vertex identified, then the ones that are 1 away from the x value of the vertex will produce the same output. The ones that are 2 away will produce the same output. So that's really, really helpful when we're graphing. H minus 1 would be 2, 1. So this should be the numbers going in order, 4 and 5. Usually when it comes to like linear equations, I tell my students, just use negative 2, negative 1, 0, 1, 2. But look here, if we use those, we would only have one side of our absolute value. We know it's absolute value. We know it should look like the letter V. So we have to choose our table of value points very carefully. Okay, so now I'm going to plug in 1. I'm going to say g of 1. And I'm going to get negative 2. And then f is the absolute value of x. I'm plugging in 1. 1 minus 3 plus 6. Inside the absolute value, 1 minus 3 is negative 2. Then the negative 2 that's inside the absolute value, we take the absolute value of, and the absolute value of negative 2 is 2. It's being multiplied by negative 2, negative 2 times 2 is negative 4, and negative 4 plus 6, there's a lot of 2's in this one, is 2. So when we plugged in 1, we ended up getting an output of 2. That means that if we were to plug in 5, because if we plug in 5, that's also going to provide a 2 here. We would have a positive 2, but when we take the absolute value, it's the same absolute value as negative 2. This one also will end up being 2. Then we can choose between 2 and 4. I'll do 4 this time. So if I plug in g of 4, I get negative 2 times the absolute value of 4 minus 3 plus 6. Order of operations says 4 minus 3 first because it's inside a grouping symbol. 4 minus 3 is 1. The absolute value of 1 is 1. 1 times negative 2 is negative 2. And negative 2 plus 6 is positive 4. So this becomes a 4 and this becomes a 4, right? Because I can use the same output. If I plugged in 2, I would also get that absolute value of 1. And now we're ready to graph. So I'm going to start with my vertex, 3, 6. It's up here. And then I'm going to go over to 1, 2, 2, 4, 4, 4, and 5, 2. Now, I chose to do a table of values. You absolutely do not have to do a table of values. I think I just missed my point there. If you want, you can kind of like use the slope as a guide. Looks like this one goes through the origin. Lovely. You could use the slope as a guide. You would only go to the right though. So you would go down 2 over 1, and then you would go down 2 over 1 the other way as well. So it's kind of like you're just going to mimic it from the right-hand side. But there we have our beautiful stretched out graph. You can see compared to the red graph that this one is a little bit kind of like a skinnier V. This has been an example of graphing an absolute value function. Thank you for stopping by.